This is Robin Burrow, and welcome to this week's PDU session. I'm the president of Omnikron. Thank you so much for plugging in to our weekly PDU, sometimes weekly, bi-weekly. Today we have a really great speaker, and that is Chris Richardson, who is really kind of a world-renowned expert on microservices. So I know in today's group, these sessions are always very rich for you attending, and then also for us because you're attending. So first and foremost, what I'd like to do is also introduce our lovely hostess, Heather King, who is Omnikron's training director. And today's speaker is, as I mentioned, Chris Richardson. Let me hear from you. If you will just nudge, and we just want to kind of share with you and give you a little tour of Zoom if you're not familiar with it yet. If you hover on the bottom of your screen, you'll see a chat. And go ahead and pull that up and say hello to Chris. And be thinking now, and I'm going to turn off my speaker because it is actually my lawn day in a minute. But I would like you to let Chris know some questions that you have, because sometimes these things are like religion. So you may be in the beginning of it, you may be in the midst of microservices, and this guy is the expert. O'Reilly, if they have a question on microservices, they find Chris somewhere in the world. So definitely, good morning, Roger. Good morning, Tracy. Good morning, Kelly and Teresa. Any more good morning? Let's hear from you. And then also just kind of stack up your questions for Chris. And hey, Brad, how are you? And Chris, with that, I'm going to just go ahead and give this to you. We're going to talk and really look forward to learning A, what are microservices, and B, how to best use them for, really a competitive architecture and enable an agile architecture in our companies. So Chris, on to you.
Great, thanks Robin. Thanks, excited to be here, and thanks to everyone for spending the time to listen. So this is a talk about the microservice architecture, so what it is and what its benefits are, and I'm going to describe how it actually, the whole point of the microservice architecture is to accelerate the delivery of large, complex software applications. Sort of another way of putting it in a nutshell is that it really enables you to do DevOps, which is the state of the art for modern software development when you're building a large, complex application. So, but before I go into that, a little bit about me. So I actually got my start in programming back in the mid-80s, building Lisp systems, Lisp being sort of somewhat of an obscure academic language. And it was one of the oldest languages invented back in 1958, and it's been evolved quite a bit since then. Eventually ended up programming in Java, and my book, Pojos in Action, came out 10 years ago, and that was all about building enterprise applications with some technologies, Spring and Hibernate, which were revolutionizing enterprise Java development. And then back in 2007, I started tinkering around with Amazon EC2, which at the time was this obscure thing from an online bookstore that sparked the whole cloud computing revolution. I was so excited by that I ended up creating a startup called Cloud Foundry that was a PaaS for deploying Java applications on EC2. And then that was acquired by SpringSource right before SpringSource was acquired by VMware. So as part of SpringSource, VMware, and then Pivotal for 4.5 years. And then 4 years ago, I left to just focus on this sort of emerging architecture known as microservices. In fact, I think in the beginning, it didn't really have a name, and it was sort of only later that the name microservices kind of was given to it. So I do consulting and training around microservices. I also have a startup, and we're building a platform to simplify the development of business applications that use the microservice architecture. And I'm writing a book on this called Microservice Patterns, which hopefully I'll be done with the writing by the end of the year. It's kind of an ordeal. And then if you want to know more, go to learnmicroservices.io, and that will just point to the book, and it points to a whole collection of online resources, articles, videos, example code, and so on. So that's me. So, here's the agenda, and it's kind of like, I'm going to start off by sort of reviewing kind of the state of the art for modern software development, and then tying architecture into that, and comparing the traditional monolithic architecture with this emerging new microservice architecture. And then after that, I'm going to talk about some of the drawbacks of using microservices. I'm going to tell you why you should use them, and then tell you why, in a sense, why you shouldn't, or if you do, what the issues are. And also, I'm going to talk about strategies for taking your existing legacy application and migrating it to a microservice architecture. All right.
Wow.
So let's get going.
I'm like ready. Oh my gosh, I got my notes.
Okay, I hope that I don't disappoint.
Chris, I haven't had the liberty of seeing the slides before, so I'm getting this all for the first time today also. Just so we take advantage of all of the folks that have dialed in today, please make sure to stop and camp on definitions, like even what is DevOps. So you might already have that planned, but we do have a mixed group today. We have a lot of senior project managers and PMO directors who maybe are on the infrastructure side, but keep hearing about DevOps. So I just wanted to make sure that we do a lot of definitions and taxonomies while we're here to get together.
Yeah, I hopefully I do define terms as I go. So in a few slides, I'm going to define what DevOps is. Okay, and as I said, if you have questions, interestingly, I'm not quite sure how to see the questions. I haven't figured out this Zoom thing. But
Heather and I are monitoring for you, so okay. Yeah.
All right, so yeah, raise your hand and stop me if there's a question that indicates I need to clarify something.
Yeah, I already can tell we have a smart group because we already have some really good questions. Okay. So I'll just try to interrupt you and just see how good of a speaker you are if you can really keep on track. No, I'm just kidding. Okay.
Oh, I've got a couple of hours this morning.
Okay. Oh yeah, it's 5 PDU session. What was I thinking? Okay, go for it. I'm sorry.
No, that's all right. So if we think about traditional software development, it was like the waterfall process, right? Where business threw requirements over the wall to architects. Architects would figure out this architecture thing, and someone else would be in the meantime figuring out how to buy hardware and all of that. And then the developers would get the design, and they do this, create the code, and then the code would be thrown over the wall to QA, who would test it, and who would then hand over the code to DevOps, so to operations rather. So you'd have this just very waterfall approach that just involved a lot of throwing things over the wall to a different team who performed a different function. And the problem you had with that is by the time some code actually got into production, you find out that the customers wanted something different. The developers find out that it's buggy, and then operations are finding out that they bought too little hardware or too much hardware. And that sort of kind of did not work so well. And so then the whole notion of agile came along. And then that's sort of been kind of subsumed into this concept of DevOps, which is this practice where instead of throwing things over the wall to a different team, software is built by these cross-functional teams that have developers, they have testers, and they have the ability to deploy the software by themselves into production. Maybe there are operations people on the team, maybe operations have provided a platform that they can do the self-service delivery. And then the other point is that rather than like spending a large amount of time building a lot of software and then putting it into the hands of the users, you're building these small increments of functionality, testing them, deploying them. So it's kind of a completely different way of developing software. So, and it's all about rapid software development with frequent deployments. And there's an excellent book on this, the DevOps Handbook. And, you know, in many ways, this DevOps and this sort of part of that is continuous delivery has been described as table stakes for playing in highly competitive industries. So, you know, internet companies like Amazon or have embraced sort of this DevOps principle, Netflix and so on. But I think that it's you know, being adopted by companies in many verticals because they need to constantly build better software faster in order to support business innovation. And there's like two metrics that kind of really come into play. One is reducing the lead time, which is the time from the developer committing a change to that change being in production. You think about in the old way of doing it, that could be measured in months, or possibly even years. And then also it's about increasing deployment frequency, which is how many times you're pushing changes into production. And that used to be measured in months or possibly years as well. Whereas if you look at companies that are doing sort of state-of-the-art software development, this is from the DevOps report, companies are pushing changes into production multiple times a day. The lead time is under an hour. So you imagine the developer makes a change, commits it, it's running in production within an hour. So they're moving fast. And yet not only that, these companies are actually not breaking things. They're actually delivering software in a significantly more reliable way than the sort of more traditional, go slow and careful approach. So that's kind of DevOps in a nutshell. You know, that's worthy of a huge, you know, that's a presentation in its own right. And where architecture fits in is that in order to develop software in sort of this rapid yet safe fashion, you need a software architecture that supports it. You need an architecture that's maintainable. It's an architecture that's testable, because one of the key aspects of DevOps is that you do automated testing, and you need an architecture that supports that. And you also need an architecture that makes it easy to deploy changes into production. So you need the correct architecture in order to do that. So that's kind of the tie-in between sort of state-of-the-art software development practices and the need to have an architecture that enables you to do that properly. So I'm kind of setting the stage for microservices. So that's process. And if we go and look at, well, what architectures do we tend to use when we're building software? The traditional approach is to use what's known as a monolithic architecture. And that's an architecture where perhaps internally it's logically layered and modular. But basically you're building a single large application. So sort of like you go to some startups and it's like, well, show me your software infrastructure, and the whole organization is just based on one large application. Enterprises will just have many large applications. And on the one hand, this is not necessarily a bad thing, because if you have a small monolithic architecture, it actually is relatively easy to maintain, test, and deploy. The problem that you run into is that if you have a successful application that people that continue to use, right, which is obviously the goal, it just gets bigger and bigger and bigger over time, because you're constantly developing it, and you're just adding more and more features. And the development team tends to grow, because the more successful it is, the easier it is to justify having developers. And then you might try and split up into smaller teams, but they're still contributing to this massive to this massive application. And eventually you just end up with this sort of monstrous application And at that point, any ability to do DevOps, any ability to do agile development just becomes impossible. And your whole development sort of rate of delivery just slows down. You know, like one organization I visited recently, their application, once it was compiled, it was a Java web application, it was 1.2 gigabytes in size. You know, this is an application that they had been developing for 10 years or more, and it was just huge. And I think that's sort of a state that many successful applications end up in. They just end up being just massive applications that are completely unwieldy. At that point, you have poor maintainability, poor testability. It can take days or weeks to actually test an application when you make a change. So, which obviously prevents you from deploying frequently. Also, you have to deploy the whole thing in one go. And that sort of means that the deployment process is quite complex as well. So that's so this monolithic architecture doesn't work well when you're trying to do DevOps once your application gets to a certain size. And then not only that, you tend to be locked into a particular technology stack. So not only do you have this massive code base that's difficult to deliver on a frequent basis, it will end up using whatever technology you started with at the start of its development, which is just getting increasingly out of date. And you sort of have no ability to do a rewrite because that would just be too expensive and too risky. So you're in this place that I call monolithic hell. So that's kind of the motivation for the microservice architecture. So it takes a different approach, and it says, well, instead of building one large application, you break it up into small, loosely coupled mini applications or services. And each one of those services performs a particular business function, or in other words, implements a particular business capability. So that's the essence of the microservice architecture. Instead of building a large application, build an application that's made up of these individual services. And so the idea behind this is, if you think from a business architecture perspective, an organization is comprised of a set of capabilities or business functions. So like for an online store, you would have order taking, inventory management, delivery management, and so on. For each one of those business capabilities, you define a corresponding service, a mini application that implements that particular business capability. So it's quite a different way of structuring your application. So one interesting aspect of the term microservice is sort of the first thing you hear is this word micro, which sort of suggests that these services should be tiny. And in reality, what the word means is that each service should kind of implement a single business capability. So it should be focused on performing a particular business function. It also means that a service should be capable of being developed by a small team. So rather than having a large team, 20 people, 30 people, or even more, as you would have with a monolithic application, with this architecture, each service is developed by a team of perhaps just 7 or 8 people. Because a team of that size is incredibly agile and nimble. They can easily make decisions and so on. So that's kind of the goal, is to structure your application as a set of services that can be developed by a small team with a minimal lead time and also a high deployment frequency as well. So if we think about the online store from its architecture could look like this, where you have services. Each service has its own data. The front end is comprised of multiple web applications, each one focused on a particular functional area. So browsing and searching could be one web application. product details page could be another. The shopping cart and checkout would be another web application, and so on. So it's all about breaking applications up by business function, and then having individual teams work on those individual services. You also would have, if you're exposing a REST API to mobile devices or the outside world, you'd have an API gateway in your architecture. So as you can see, which kind of hints at one of the downsides of the microservice architecture. There's many more moving pieces, but you break it up in this way so that each of the pieces is smaller and much more easily developed and deployed. So it's kind of a trade-off there. So the idea is that this gives you much better maintainability. It's much better testability. And it gives you much better deployability. And the essence, the whole motivation for this is really going back to this notion of DevOps and continuous delivery, is to enable you to do that for these large, complex applications. And I think the majority of organizations who are able to deliver software quickly are doing that because they're using the microservice architecture. And it kind of fits in with continuous delivery and DevOps in two ways. One, it gives the microservice architecture, gives you the testability and the deployability that's needed to do DevOps. And it also enables the individual teams to be autonomous. So imagine that you have all these different teams working on a monolithic application. They're all contributing to the same code base, which requires a lot of communication and coordination between the teams. When they're developing microservices, each team will own their service or a set of services that they can develop, test, and deploy independently. So there's sort of a lot of synergy between the microservice architecture and modern development practices. And then as an added benefit, the microservice architecture lets you much more easily evolve your technology stack. So when you're building a new service, you can pick a new modern technology stack. You're no longer constrained to use the same old technology stack throughout your application. And then also, you're making major changes to a service, you could rewrite it using a new technology stack. So it lets you incrementally upgrade your application. And it does it in a way that lets you sort of try out new technologies and fail safely. If you try a new technology, a new language, and you decide that you don't like it, you can simply just say, well, we've learned something, we're not going to use this language going forward. And it just means that one small service is going to need to be rewritten at some point. It's not a huge failure. So that's sort of the microservice architecture. In its essence, the idea is, instead of building one large application, you build and you break it up into a set of services, and each one of which can be developed and tested and deployed independently. And there's tremendous value. But at the same time, the microservice architecture really is not a silver bullet. Fred Brooks, the author of the Mythical Man Month, kind of used that term in a speech 30 years ago. He said that there's no silver bullets in software development, and that is very true, and that certainly applies to the microservice architecture. There's several drawbacks. One is it introduces a certain level of complexity. You're building a distributed system, so you have to deal with all of the issues that come with that. Inter-process communication, this concept of partial failure where some services might not be available when you try and invoke them. Your data is scattered around multiple databases. Testing is simultaneously simpler because the individual services are smaller, and hence easier to test. But at the same time, there's the complexity of making sure that the services can work together. But the good news is that there are frameworks and patterns and testing strategies that can address these complexities. And then also deployment is more complex as well, because you have essentially an order of magnitude more applications in production. Instead of just running multiple copies of your monolith, you've now got tens or hundreds. And in the case of some companies, they have thousands of services in production, each one of which needs to be monitored and managed. The good news is that there are highly automated deployment platforms based on Docker containers, for instance, that can tackle this kind of complexity. So it's sort of like, on the one hand, yeah, there's this complexity with microservices, but on the other hand, there's complexity with a monolith, and the monolith will only ever get more complex, and there's no solution to that. Whereas with this kind of complexity, there are solutions that can reduce the complexity. But you always have to ask, are microservices a good fit for my application? You know, it really isn't some sort of silver bullet that will solve all of your development practices, development issues. And you also need to ask, is my organization mature enough to be successful with microservices? Are we good at automated testing? A lot of clients I talk to need to first improve their automated testing skills before adopting microservices. They also need to have in place the ability to automatically provision infrastructure. So moving away from the manual configuration of machines to fully automated cloud-like environments is another important prerequisite. So there's all these skills that you have to have in place before you should think of adopting the microservice architecture. And then if you do, there are sort of numerous technical issues that you have to address. And we're not meant to read that slide, but the upshot is that sort of whether you should use the microservice architecture, you know, it depends. And then if you do, how you use it, there's a whole bunch of decisions that need to be made. And one of the things that I've been working on to make these decisions easier is what's known as a pattern language. That's a collection of patterns that solve various architecture, design, development, and operational issues with the microservice architecture. So a pattern is a reusable solution to a problem that occurs in a particular context. And the concept of a pattern was popularized by the Design Patterns book that came out 23 years ago. And it was a collection of object-oriented design patterns. So it's in a particular domain, object-oriented programming, but the concept of a pattern is actually much more general than that. And it's this incredibly valuable way of representing knowledge or representing solutions to a problem, because it does it in a very objective fashion. And so if you actually look at the structure of a pattern, it has a name. It has to describe the context, which is the situation within which you're trying to solve a problem. It also has to describe the forces, the various issues that are relevant that need to be addressed by when you solve this problem. You know, it describes the solution. And then the other two sections of a pattern are actually really, really important. There's the resulting context, which describes the consequences of applying a pattern. So it describes the benefits, which is what people normally focus on. It's like, I love technology X because it gives you these benefits. Yet at the same time, every technology has both drawbacks and issues. So the pattern format forces you to describe the drawbacks, the downsides of using a particular pattern. So in the case of microservices, the benefits are it enables you to go fast. The drawbacks are, well, it's complicated in a variety of ways. And then there's various issues that you have to address. Oh, I'm building a distributed system, and so we have to solve problems, solve issues X, Y, and Z.
Chris?
And then there's this, so this basically forces you to describe kind of the downsides and the issues, which kind of is a much more honest way of representing a particular technology or a particular design choice. And then there's also another section is related patterns. So these are patterns that are either alternative solutions. So instead of using the microservice architecture pattern, you can use the monolithic architecture pattern. And then there are patterns that solve the issues that are introduced by this pattern. So if you look at this pattern language, microservice architecture is a pattern. The monolithic architecture is an alternative pattern. And then there's a large number of patterns that solve the issues that are introduced by using the microservice architecture. So this slide.
Chris, can I ask a question?
Oh yeah, sure.
Can you go back?
Oh, this one?
The one you were just on. But yeah, fill that in for me. So give me an example of forces, because that for me is a little bit muddled with, the drawbacks and alternatives. So give me an example of a force.
Oh, so a force, I mean, I think a simple way of just thinking of a force is that it's almost like a requirement. So sort of like the context would be, we're building a large complex application, right? And then one of the forces would be, well, we want to deploy changes into production many times a day.
Oh,
or
okay.
Developers need to.
It's like a criteria.
Yeah, I mean, it's like it's like an issue that you have to address.
Okay.
So I think maybe I feel like requirement is probably the kind of closest analogy.
Okay. All right. Thank you.
Developers need to be productive. We want our tests to run within, we want to be able to test it in under half an hour. Those kinds of sort of requirements.
Okay. Thank you.
No, that's a good question. Thanks for, because that is a kind of a, and it's one of the forces is sort of
Yeah, I'm thinking of forces, like competing forces, or I'm a business person, so I'm thinking about like market forces or something. So thank you.
Yeah. Well, it's like, it's a very overloaded word that means different things in different contexts. And in the context of patterns, it has a particular, has an entirely different meaning.
Excellent.
So yeah, and if you look at, so this is the pattern language, which is kind of, I'm not going to go through this. So if you want to know more, go to microservices.io. So I'm quite sure how many patterns are on here, but they're kind of addressing various different issues around deployment, inter-process communication, how to actually break up, there's some decomposition patterns, strategies for breaking up a system into services. And then there's a collection of data patterns as well, which are how to deal with, how to implement queries and maintain data consistency when you've broken up your system into services, each one of which has its own database. And then there's testing patterns and so on. And if you, and they all follow this pattern, have that same structure of basically problem, solution, resulting context with benefits, drawbacks, issues, and then related patterns. So I encourage you to go check it out. So that's sort of the microservice architecture, what it is, what its benefits are, and then also what the drawbacks are. And then the final thing I wanted to talk about really briefly before we kind of have questions is just sort of the thing is, well, so I've got my monolithic application. And yeah, development of it is slow, and I'm trying to do automated testing and all of this other good things, and I'm still not able to go fast enough. And so there the issue is, well, how do I break up this big, scary application into a set of services? And this is actually a form of application modernization, which is something that people have been doing basically, I think, since the first application was written. Like, we want to upgrade, we want to modernize this application in some way. And, experience has shown that the best way to do this is in an incremental fashion. So don't go off and sort of do a big bang rewrite of an application. What you want to do is use what's known as the strangler pattern. And the idea of this is a metaphor. So in rainforests, you have strangler vines that grow up around trees. The vine is trying to go up towards the light, and so it grows up around the tree, and then sometimes the tree dies and you just have this tree-shaped vine structure in the forest. And so that's the metaphor. The tree represents your legacy monolithic application. The vines represent a new application that you're basically incrementally building up around the old one. And so the idea basically is, on day one, you have just your monolith. On day two, or perhaps month two, you have a monolith and a service. And maybe the monolith has got a little smaller. And then a month after that, you have a monolith and two services, and so on and so forth. And so bit by bit, your monolith is shrinking, and its functionality is incrementally being replaced by a set of services that you're building up around it. And there's a couple of patterns that you can use. So one of them is just implementing new functionality as a service. So, requirements come in to implement some major new functionality. At that point, you have a choice. You could make your monolith bigger, but that would be basically, it's like you're in a hole, and that would just be making the hole deeper, right? So instead, you implement your new functionality as a pristine, beautiful new service that you can develop using DevOps. So your monolith is sort of on the slow development track. And then any new services you build are kind of on the development fast track, because you're now free to do DevOps. So that's the model: new functionality, implement it as new services. And so over time, you're going to have all of your new functionality built the right way with microservices. Turns out that it's actually a little bit more complicated than that, because the services almost always need data that resides in the monolith. And so either they're going to update it or they're going to read it. So you have to implement some data integration glue, which is shown here as a separate box, but in reality, it's some code in the monolith and some code in the service that enables the service to access the monolith's data. And that can be one of the more challenging parts of doing this refactoring effort is doing the data integration. But this is one pattern: implement new functionality as services. But then the bulk of the refactoring effort is incrementally breaking up your monolithic application. So in other words, identifying modules inside the monolith, and then essentially hacking code to decouple that module from the rest of the monolithic application. Because the next step is to then extract that code and turn it into a separate service. So, and this is actually quite a hard, complex step, because you're likely to have to break a lot of dependencies, and this is a long-term effort. It's not something that you can do overnight. And it sort of just basically requires spending a whole lot of time just hacking away at the code. But this is something that if you want to escape monolithic hell, this is, you just have to do this. And many organizations have successfully done this, but it is sort of a multi-month, multi-year effort to actually break up a large monolith and turn it into services. So that's pretty much all I had to say, right? So sort of to summarize, modern software development is about DevOps and continuous delivery. In order to do that, you want to use the appropriate architecture. So if you're building something small, monolithic architecture is just fine. But if you're building something large and complex, you're going to have to use the microservice architecture. The pattern language that you can find at microservices.io, you can use that to decide, to guide your decision making. And then if you want to use the microservice architecture, then you'll have to incrementally refactor your monolithic application into a set of services. So that's my talk. Thank you for listening, and you can find contact info here, Twitter and email. Then it also Learn Microservices is sort of the landing page, so to speak, that points off to all of my online resources. So thank you.
Thank you. I have a bunch of questions. So I have so many questions. We really opened this up. Let me ask this one from Mardesh. I'm probably not saying that right, but he wanted to know, how do people feel about products and approaches such as Docker?
Oh, yeah, that's a great question. I mean, this is quite interesting because Docker and microservices are sort of used interchangeably. So there is this sort of myth that if you put an application in a Docker container, it's a microservice at that point, which is not really true. They're actually two separate concepts. You can deploy a monolithic application in a Docker container, but just wanted to clarify that point. But Docker is actually is a fantastic deployment technology. Just this week, I've been working on the deployment chapter in my book, and it was like causing me to just think back about how deployment has evolved. And, was it 10, 15 years ago, if you wanted to deploy an application, that meant buying physical servers and putting them in a data center. And then, 2007, 8, AWS cloud came along, and all of a sudden you could just provision virtual machines and pay for them by the hour. So, our concept of a machine suddenly went from physical to virtual. And then in the past few years, was it 4 or 5 years ago, Docker was invented, which is an incredibly lightweight virtualization mechanism. And to me, it's one of the key deployment technologies for microservices, specifically if you're using a higher level Docker orchestration framework like Kubernetes. That's hugely powerful. And then in a sense, there's something even more modern than that. There's this whole called serverless technology, such as AWS Lambda, that's basically 3 years old now, which is even more lightweight and sort of more ephemeral. So, essentially 15 years, we've gone from physical machines to virtual machines to containers to Lambda functions. And it's actually quite incredible.
Yeah. Considering so many people, what was really interesting about one of the comments that you just made is in 2007 or 2008, you could just spin it up in AWS cloud. And however, most of my customers are just reeling from putting things into AWS cloud now or Azure. So I know we could have done it 10 years ago, but most of my customers are just doing it now. But okay, because Mardesh, I hope I'm saying your name right, but I agree with you. So we have another item that's come up also from, I think, Michelle as well. So the integration concerns are concerning. Based on Mardesh has personal experience. And Mardesh, if you want us, we could also promote you to a panelist so that you could talk if you want to. So just let us know. But yeah, the integration concerns are concerning. I like that. Can you address that?
Yeah, I guess maybe you could promote him, because I'm curious to know what he means by integration concerns.
And it's up to you. So I'll wait for that chat.
Or maybe you could just elaborate on integration concerns.
Integration concerns are up to you all. Do you want us to promote, Heather? Let's promote Mardesh and just see if we can get, we have to promote you to panelists in order to get you to be able to come online. But while we're doing that, let's see, did we get Mardesh?
No, I opened it for them to chat or to talk.
Okay.
So they should be able to come off mute.
Okay.
Let me try that. Is that better?
Yeah.
There we go.
Yeah, and Mardesh isn't a guy either, right?
Yeah, exactly.
Sorry.
So I often refer to this. I'm originally from Canada, and before I left Canada, there were no fishermen or policemen. They were police people and fisher people. And more I'm beginning to think we should all adopt that approach.
We should all be people. Yes.
Yeah, because that way it's non-gender based, right, which is nice. And given some other problems in our society right now, I won't go into. But anyways, what I was referring to is my experience or background is in Oracle ERP. And of course, they started out as individual applications, which were then pulled into a sort of common underlying framework. Unfortunately, of course, because they were different applications that were produced by different companies, as they were pulled in, there were problems with it. We found that as we tried to integrate the different applications, like certain parts of PO purchasing would go with potentially somebody we would also sell something to. A vendor may cross different, classifications or apps. What we found was that to integrate and make sure that all the teams work together in terms of their architecture, any changes they made at all, and making sure that the stuff still works when it got to the client in such a monolithic application as ERP, right, where you're using all these different features in a company, many features, was very difficult. And the only thing we came up with in the end, it was just before I left, was literally to have a separate integration team that would, as you said, though, also make sure that all your test cases are automated and run them across the entire ERP, call a freeze at a certain point and say, okay, at this point, we're definitely going to go and test everything to make sure we have no issues. And then you release your product and pray that somebody doesn't blow you out of the water later on. I don't know what your experience with that is and if there's a solution.
Yeah, okay, so, right, so it's sort of integration as in sort of integration testing. Yeah, so that what you're asking about is one of the sort of the testing challenges. So it's sort of like you have this kind of irony that the individual pieces are a lot easier to test, but then there still is a requirement to make sure that they all work together, which is, I think, is what you would integration. So if you, on one strategy is to do an end-to-end test, but that, once your system gets to a certain level of complexity, is incredibly brittle, it's very slow, and it's also pretty expensive to implement, just because it's just challenging to write and requires a lot of effort. And it's interesting, if you go Google the testing pyramid, and kind of end-to-end testing is basically near the top of the pyramid, and the idea is you want to do as little as that as possible. So instead, there are these testing patterns that you can use where you actually test the individual pieces, but you can do it in a way such that you can be sure that the pieces will actually work together. And there's in particular, there's this testing technique called consumer contract testing. And so let's imagine the order service calls the customer service. So the way that would work is that the order service team would write a small test suite for the customer service that verifies that the customer service behaves as they expect. And then they would they would actually give that code to the customer service team, who would just run it as part of their test suite. And so that would ensure that the customer service behaves in a way that meets the expectations of the order service. So that's kind of a key testing technique that addresses this sort of integration issue.
And Chris, again, that was called consumer contracting.
Contract testing.
Thank you.
I think we called that functional testing, which, of course, you do as well. And like I say, you automate the heck out of it wherever you can, and that speeds it up. But yeah, I appreciate what you're saying. It's as you said, though, you still, in your presentation, you still do have a problem with integration. I mean, even to get developers to say, test, I'm doing a piece of code. Okay, that works here. Yeah, but it doesn't work when you pass the data to the next person. You know what I'm saying?
But if you look at what companies have successfully built, so like let's just say Uber or Twitter or Netflix or Amazon, they have built systems that are made up of thousands of services,
right?
And you can be pretty sure that a developer is not going to spin up 1,000 services on their laptop to run an end-to-end test, right? And
but
so,
Chris,
no, it's got to be automated.
I have a question about that, because did they really refactor old legacy apps, or were they starting from scratch? I think that's a big difference. If I'm spinning up thousands of services and integrating them versus if I'm going to take one of my old, legacy apps and then try to rehack it and reconnect it.
I think you're right. And I think, too, the other point is that if you're talking about a financial application that's going to run your business globally, right, and has all these, extra features in it and complexity in it because of those kind of things, versus Google just says, because, having known people that work there, it just says, you know what, this is where we're offering you and this is the way it is. And if we go down for a little bit, we don't care. Like, for example, apparently and maybe you know this as well, Chris, but their initiation or envisioning to actually delivering code is very short, because they just stick it in, and if it fails, they'll pull it out and they'll try and rejigger it. You can't do that with a major corporate application that's running the corporation, both financially and purchasing and all kinds of other stuff, if that makes sense.
Yeah. I mean, in theory, you're right, but if you go look, like, remember that slide I had that, which was like moving fast and not breaking things, right? So, for instance, companies like Amazon, which is, that is a global business, and their uptime is really, really important, because that means, being up means they sell stuff, being down means they don't.
Right. I'm thinking more little pieces of their app is what I'm thinking. So my understanding is they'll take a piece and they'll modify it, right? Do some work on it, and they'll go on that particular function and they'll update that. Now, there's certain core functions, my understanding is they test further, but they're talking about something that, here's a little piece over here, I'm going to update it and let's see what happens. They have had to roll it back. More than once, yeah. Whereas you can't do that in an ERP, right? You're selling the ERP. It's not Google. You're providing the service.
Actually, that's a really good point. I think what you're drawing a distinction between is basically SaaS, or SaaS, software as a service, right?
Right.
And which is a big, a lot of interesting software is SaaS today, right? And then the actual traditional package software. When it's packaged software, that's a whole other problem. I mean, effectively, I suppose I should have clarified that. I mean, my talk is very much as opposed to packaged software development.
So Mar, thank you for very, very much. I think we could spend a lot more time on that, on the subject of course. I mean, it's a really big subject. I want to make sure that we, and thanks Chris for handling these things. We have another couple questions. Kurt has asked a couple questions, but Heather, I don't see those. Can you ask Kurt's questions?
Sure. Kurt asked, the first question he asked is, are there any case studies that you can share that compare traditional to DevOps that show improvement metrics?
Yeah, I'd have to go research that. I do recall that like this week or next week in San Francisco, there's the DevOps Summit, and I believe it's like the DevOps Enterprise Summit, and I believe that people there have given presentations, you know, from large companies saying, hey, we adopted DevOps and things went a whole lot faster. So I think there's a whole bunch of case studies there.
That's good. Thank you for that. DevOps conference in San Francisco.
The DevOps Enterprise Summit.
Okay. And guys, I know if you had to go to another meeting, we're going to just keep recording for Q&A, and then you'll still have access to this later. So
just say is, you know, if there are questions that you have that I do not have, that there's not time for me to answer, please just send me an email, and you know, I'll do my best to reply in a timely way.
That's great. And Heather and Brad, Heather, do we have any other questions? And Brad, I think
yeah, Kurt had one more.
Okay.
We are bound by regulatory compliance and SDLC. Is there a modified SDLC approach that covers the DevOps model?
Yeah, I mean, I think there are certain sort of regulated industries that, at least on the surface, seem to kind of have, you know, present obstacles to DevOps. But I do believe that people have actually done DevOps-y type development in regulatory, you know, heavily regulated industries like financial services. I don't have any case studies off the top of my head, but I think if you go Google, you can find some. Or shoot me an email, and I'll get back to you on that.
Okay, good. And Brad, I wanted to give you an opportunity. Thank you, Chris. Thank you, Kurt. And we can keep the discussion going via email and also via chat after. Brad, did you have a couple things?
Yes.
What's this very interesting slide I see, Brad?
Hey, you know what? Can you hear me okay?
Yeah.
It's awesome. I basically just wanted to give everybody, I think what we're going to start doing is doing a 30-second did you know commercial at the end of our awesome presentations. Chris, nice job today. That was awesome.
Oh,
thank you. So I'll just be really quick. You know, pretty much we don't want to sell anybody on the line, but we definitely want to keep you in the know. And it's come to our attention over the past PDU webinars, communicating with some of the attendees that a lot of people didn't realize, you know, Omnicron being a global IT training company, that you have, if you are one of the fortunate ones that work for an organization or company, and you have a tuition benefit of some kind, pretty much almost all tuition benefits are usable or can be used at Omnicron. And the reason for that is Omnicron has unique partnerships with major universities that have all the accolades and credentials, which makes our certification courses available to you, to whether you want to get the certifications, or you're just looking for PDUs, or you're looking for leadership or professional skills training. You have access to our entire menu. So if you do have that tuition benefit. You're not quite sure how it works, how to use it. I'm actually one of the tuition assistance experts at Omnicron, and I would be more than happy to sit down with you over a phone conversation and explain to you, I am going to use this word, how easy it is to use. So that's all I wanted to say. This was your 30-second did you know? Hopefully that 30 seconds a little went over, but hopefully it added value to you. If you need to get a hold of me, you can email Heather, or you can email myself. It's just my name there, brad.emm@omnicron. I would be more than happy to sit down with you on a one-on-one and make a plan for you. And you still have about a month and a half left to leverage that beautiful benefit. That's it. I'll hand it back to you, Robin.
Such a good benefit. Thank you, Brad.
Yes.
And thank you for, I got a bunch of people that said thank you so much. Really, really appreciate the comments, Chris. I have a curious question. And again, if you have to go, that's okay. No problem. We totally get it. And we will keep this recording going. So this is a personal question. Chris, what is that startup that you alluded to? I can't keep my curiosity. My cat was hanging around, right? So
Oh, you're talking about eventuate.io.
Yeah. What is that?
So it's basically, I mean, it's a platform, sort of an ambiguous word. So there's several different pieces to the platform, but it's fundamentally supporting an event-driven programming model to simplify the development of business applications that use the microservice architecture.
Okay, good. So it's something that we're going to need in the massive integration map that you showed us. Good. When's it going to be done? When can I have it?
Oh, well, there's like a beta version of it available now. There's several different parts. There's a SaaS version that's in beta, and then there's some open source projects that you can start using today for your development.
So where do I go?
Eventuate.io.
I'm chatting that out. Excellent. Okay. Thank you, Chris. That's very good. And when's your book going to be done?
Don't talk about my book.
It's writing is horrible, but having written is wonderful. Isn't that the famous quote?
I hope to be done with the writing by the end of the year.
Okay.
So like the ebook, so the kind of like early access version you can actually get today if you go to manning.com.
Okay, what is that? www.manning?
Yeah, manning.com. So that's the publisher.
And what's the name of the ebook again?
Microservice Patterns.
There was an acronym on the front cover of that book.
There was one on my
MEEP. What was that?
Oh yeah, okay, yeah, that's the Manning Early Access Program.
See, I'm paying attention.
I'm impressed.
Very good. Okay. All right. So I've chatted that out to everybody, I hope. And Chris, let's confer later. I don't know how long you're going to be in the States. How long are you here for? Or?
Oh, I'm not flying for at least a few more weeks.
Okay. All right. Well, let's try to connect while you're still here. And for everybody that attended today, thank you very much. We will be getting you the recording and the slides. And there's a PDU option also. But Heather, I think the question was, if you fill out the survey, you will get an extra PDU. So if you're still with us, how many people are still with us? 22. So for those of you that are here, and we'll just email the rest for your extra PDU, if you're collecting PDUs for the Talent Triangle for the PMI, this goes in the technical section, and you can get an extra PDU, so 2, if you answer our survey today. We always also like your comments and your questions, and any question that you have for Chris, and if your company is currently embarking on a microservices project, or you're in the midst of something and pulling your hair out, email us and we'll connect you directly with Chris, because I think that would be cool.
help.
And with that, thank you. Thank you, Heather. Thank you, Brad. Thank you, Chris. And thanks, everybody.
Thank you. Have a good day.
Thank you. Bye-bye.
Bye.